So one of the things I noticed on the homework problem, especially the like calculate scoring play, where I called the function 5 different times, a lot of people initially when they defined the function created 5 different parameters. When we're trying to see how many parameters are in a function, we just look at one function call. So we could have called this like 100 different times if we wanted. What's important is for one function call, how many parameters are in the parentheses. And in this case, there's just one parameter. Yep. Any questions here? Okay. So 1. Next question. Return type. This one's kind of asking you to answer based on the context. Try to guess what this function is doing, and then what the return type should be. Okay, cool. So what is this function trying to do? Calculate the area of a circle. So is that going to return like a number, a word, true or false? It's going to be a number, and it's most likely going to be a decimal number. So in this case, we would have the return type be a double. Everyone good there? Okay. All right, number 3. How should the function be defined? I think this is the hard part for a lot of folks. Think about the answers to the previous 2 questions. They'll help. Okay. Split between a couple answers here. Okay. So first, on the previous problem, what was the return type that we said? Double. So we know it's going to be either answers 1, 5, or 7. Because we know the return type is a double. All of them have the same name. And so then the part that I think even on the homeworks are tripping people up, what goes in the parentheses? So first off, how many parameters does this problem have? 1. That's what we answered on the first problem. So we know there has to be 1 parameter at least. So that eliminates this answer. Because how many parameters does this answer have? None, right? So we're left with, out of these 3, we already eliminated line 3, so we're left between these 2. Essentially, to calculate the area of a circle, we're asking for the radius. We need to know what the radius is in order to calculate the area of a circle. Is the radius going to be, char is typically a letter, double is typically a number with a decimal. So which one is it going to be here? It's going to be a double. Right? We can't do a mathematical operation with a letter. It has to be a double or an int, but we want it to work for any number, so double is a better option. Questions here? Okay, I think this has typically been the hardest part for students on the homework, so defining the function. So can people put into questions or what some of the hard parts are? Just more practice? Okay. All right, leaderboard keeps changing. Next one. What is wrong with this function? A couple more people, get your answers in. Okay, cool, so let's take a look. So we came up with the function header earlier, so function header is okay. Why is it okay to just use radius here? Why is it okay to just use it directly? Yeah, so we define it in our parameter list as a double, so we don't need to define it again in the function. We already defined it in the header. So this is okay. What does pal radius 2 do? Yeah, so this is a built-in math function, and it takes two parameters. The first parameter is essentially your base, and the second parameter is the exponent. So this is saying radius squared. So we have pi r squared. We store that value in area, and then I see some students do this. We say the return type is a double, so we can't just like see out the area. We have to return the area. So it's missing a return statement here. Yeah. In the main function, whoever calls our function, they can decide what to do. They can print out the radius, they can print out the area if they want, or they can do something else. But the point of our function is just to do this very specific task. It's just to calculate the area, return it. Yep. All right. 2 more questions. Which of the following functions do not return anything? Nice. I think people... Okay. This one's really just testing how well do you remember the syntax. We always have to put a return type at the start, so we like line 3 would never work. This one, like, it's a 0. This one is a 0. It's just not the right syntax, but it's the right idea. Essentially, we need this keyword void if the function's not going to return anything. Okay. All right. Final question, and then there's a poll. This one changes gears a little bit. Just a quick question on for loops. Which of the following do not go in the for loop header? Oh, sorry. Okay, yeah, just, yeah. Variable initialization, then condition, then update. Okay. How are you feeling about functions? Let's get a general poll. Okay. Pretty even spread. Again, every homework and lab assignment from here till the end of the semester is going to be using functions, so there'll still be a lot of time to practice. But if you feel like you're struggling with setting up the function in later assignments, like come in and get extra help. Because as we learn new stuff with arrays, like we don't want you to still be learning how to do functions as you try to do array problems, right? So if you need any extra help, you're always welcome in office hours, and we can go over it in more detail. All right, podium, 6 out of 6. Cam, nice. 20 points higher, Ben. And nice. Congrats, everyone. Jamali and Agent 7 as runner-ups. All right, cool. Any final questions before we go to new material? Yeah. Void is if the function does not return anything. Yeah.
When will we use that?
Really, the best example I can think of is if you just want your function to print something, but not really do any calculations, then you could. So if it was like, if you're building a game and you wanted to print like stuff in your intro screen, so it'd be like intro message or end message, then it could be nice to do that in a separate function so that if you ever wanted to modify it, you would know exactly where to find your intro and end. Yeah. Okay. Any other questions? Okay. Before we get into arrays, it can be helpful to think about it, what a variable is first, and then we can compare and contrast variables versus arrays. There were kind of 3 things. Way back in lecture 4, we talked about 3 things that are important to a variable. Does anyone remember any of them?
The name?
Yeah, so it has to be uniquely named. We can't have multiple variables with the same name in a function. Robert?
It needs to be true at first.
So that would be for the like loops. So for variables, they don't, like if it's a string variable, it doesn't have to be true. Brian?
A variable can change.
Yes, a variable can change. So building on that, yep.
Start with data type.
Yep, we specify what the data type is. Anything else? Okay, so the fact that it can change kind of ties into the fact that it's a placeholder for data. So it's not the actual data itself, it's a name that represents some other piece of data. And specifically why it's used, variable uniquely named, it's a storage location. So the variable is really used to tell what memory location the data is stored at. And so the data can change as the program goes along, but the memory location will never change. Okay? Everyone good with this? Okay, before we give the definition for an array, I just want to explain why arrays could be useful. So let's say you were the mail person and you had to deliver mail to the house at the 5th row and the 3rd column. What color house would that be? 5th row,
On the bottom, what's up?
up to you. 5th row, 3rd column. What color house?
Green.
I heard a gray.
No, green.
Green?
Pink.
Green. Pink?
Third column?
Yeah.
It's pink.
Pink?
Yellow.
Yeah, pink.
Pink? Blue, yellow.
It's green. It'll be pink.
It's 6 rows, bro.
5th row.
Nah.
No, wait, hold on.
Okay, I'm curious to do a poll to see if you match the morning class or not. All right, if you think it's blue, raise your hand.
5th row, 3rd.
Yeah, 5th row, 3rd column. Okay, I see 3 for blue. All right, how about yellow? A couple for yellow. Okay. Green. Okay. Oh, green's looking popular. All right. What have I not said yet? Pink. Pink. All right. Oh, pink, heavy favorite. Okay, I think pink's the winner in this class. I think morning class the winner was blue. Okay, point is you'd be a sad mail person if you had to deliver because it's not organized, right? One of the benefits of arrays is that it can help organize data. So it'd be easier if we could line up all the houses in a single line, essentially as a list. With arrays, we start 0 indexed. And partially the way why it is if you're the mail person, you can think of it as if you take 0 steps, you're already at the gray house. So computers work in terms of offsets. And so if this is the start of the memory location for the array, you don't have to offset by anything to already be at this first element. That's the reasoning why we start 0 indexed in computer science, both with strings and with arrays. If you take one big step, then you'll end up at the greenhouse. So the houses of 1. This syntax looks very similar to what we were doing with strings. To get a letter in a string, we were saying like word of 0, word of 1, word of 2. Arrays look very similar. If we wanted to say the blue house, how could we represent that? Houses 3 or houses 4? 3, right? Because we started 0. So 0, 1, 2, and then 3. Houses of 3 would give us blue, right? So now the mail person knows we can tell them go to houses of 3, and they'd be able to know go to the blue house, okay? So one benefit of arrays is it's easier to organize information. The second is that it's easier and more efficient to access and move information as well. So let's say we had 1,000 houses. We could represent those 1,000 houses with variables. We could have house 0, house 1, house 2, house 3, all the way to house 1,000. But now let's say we wanted to print out the color of each of those houses. How would we have to do it? See out house 0, see out house 1, see out house 2. We would have to see out 1,000 times, right? Very inefficient, very hard to do anything with big chunks of data. With arrays, 1, you can define the array on a single line. But 2, if we wanted to print out every house, even if we had 1,000 houses, we could do it in 3 lines of code. Can anyone take a guess how we might be able to do it in 3 lines of code?
What are we trying to do?
like print out every house in the array. What's up?
Like it'd be like if you string house index,
Mm-hmm.
and then what we have to do would be like a while loop.
Yeah, so we can do a while loop or a for loop. Like we could have a for loop where index starts at 0, goes all the way up to 999, and in the for loop we can just see out house of index. That way it prints out house of 0, then house of 1, house of 2, house of 3. The powerful part with computer science is you have thousands of pieces of data, you can store it in an array, and then with a loop, process every piece of data. If we didn't have arrays and if we had to do everything with 1,000 variables, you lose all the power. Because as a programmer, you would have to write, like if you wanted to print out every house, you would have to write out 1,000 different lines, right? So are people starting to see why arrays could be useful? Question? Yeah.
Can we do it with other data types, or just string?
So you can do like a string array or a double array. And that would store like a bunch of strings or a bunch of doubles. But the overall concept is called an array. Other questions? Okay, so how many pieces of data can a variable hold?
As much as you want.
A variable,
Variable.
yeah.
Variable can only one.
A variable can only hold one value. But how much can an array hold?
As much as you want.
Essentially as much memory as your computer has. So that's really the difference in the definitions. Arrays are essentially like variables. They are uniquely named. They reference a memory location. On the next slides, we're going to go over how it actually works. But they are uniquely named. They do reference a memory location. The difference is an array can hold as many pieces of data as it wants, whereas a variable can only hold one piece of data. Okay? Questions here before we go into the syntax?
So.
Okay. Cool. So let's look at how it works under the hood. So if we wanted to define an array, it almost looks identical to a variable. I copied the variable definition slide, and I just changed a couple things. The data type, you still have to say what the data type is, just like with a variable. Name, you still have to say the name, just like with the variable. What's the difference here?
The size.
Yeah, so we put these square brackets and we say what the size of the array is. So when you're defining an array, you need to specify what the size of the array is. And what the computer is going to do when it sees this, it's going to go and find some open spot in memory. And if the size is 3, it's going to save 3 different memory boxes. In this case, because it's an int, each of these memory boxes are going to be 4 bytes long, which is why we started like some random memory location at 1,000, but then the next int would be at 1,004, and the next one would be at 1,008. If we made this double ages, then it would have been starting at 1,000, maybe then 1,008, then 1,016. Okay? So how can you tell how much space an array needs? Like let's say we had a double with 5 ages. A double array with 5 ages. How many bytes of memory would need to be saved? So a double is typically 8 bytes. So if that, not quite 32. So we're going to do 5.
You said 8 and 5.
Yeah, 8 and 5, yeah. So we essentially take how much ever memory one double takes, and we multiply it by how many doubles are going to be in the array. So if we had an array of 5 doubles, that would be 40 bytes. If we had an int array of 3, that would be 4 times 3, 12 bytes of memory would need to be stored. So that's what's happening in the definition statement. The computer is going and finding memory to store this data. Okay? Any questions here on how to define an array? Okay, I'm going to have you all define 3 arrays. We'll do it in groups. Have each person in the group write at least one of them. 2. Of you 2 here. 2 here. 7. Here.
And then string letter.
And we need to put the quotation.
I'll be finding out. So we don't need to visualize them yet. We'll just do just some string name 7, 6, semicolon. So the other 2.
What is it? I couldn't read it.
Okay, then don't forget the semicolon.
I thought you put how many.
I forgot. Wait, okay, I forgot there's any brackets in there. I'm not even that tired.
Double.
I mean,
But
because, okay, we need like string, then names, right?
Okay, cool. Let's bring it back. I think people are on the right track. So array of 7 names. What is that going to look like? Yep. One general, it's kind of a style thing, but when naming arrays, it's generally good to make them plural because it's going to be storing multiple names. So it's generally good practice to make them plural. Question?
why is it 7 and not 6?
So the indexes will go from 0 to 6, but the size of the array is still 7 elements. So yeah, on the next slide we'll kind of share the distinction, but when you're defining it, these square brackets are just saying what the size is. And yeah. Good question. Other questions? Okay. Array of 5 letters. Yep, char letters 5. Cool. And then array of 15 test scores. Double. Yeah. And so note when we name these array variables, they're still lower camel case. So the first word is all lowercase. The second word, we capitalize the S here. Okay? Question?
So what would it be if test scores?
Like a score could be like 90.5%. Like we want to generalize it for any case. And some professors might give 0.5. I think even on mine, people got 0.5
The way I
points.
was thinking about it, I was thinking about if like one paper is 1 test score.
Yes.
So like every test score is tally up by 1. I wasn't thinking about the score itself.
Okay. So like this would store like 15 separate test scores. And this data type is referring for each element. What is the data type? And for each of them, some of those test scores might have a decimal in it. So we want to make sure that, yeah, they're all good. Okay, other questions? Okay. So now array assignment. So this just allocates the spot in memory. They all have random values. So we saw with variables, if we didn't assign a value to a variable, then we saw our code would sometimes do wonky things. If, it would just give us some random value. Arrays are the same way. If you just had this line int ages 3, and you tried to access any of these elements, you would get some random value. So this slide shows how we can assign a value to a variable. We have ages of 2 is equal to 18. Can anyone guess what happens on this line?
18 is
Yeah, so we go and find index 2, which is here, and this value will change to 18. Okay? There's a super key distinction here. On this line, when we use the square brackets, what did the square brackets mean?
How many elements?
Yeah, so this was just to specify what the size is. This line, though, what does the square bracket mean? Here it means the index. I hate that C++ uses the same symbol for both, even though they're doing different things. It's confusing. Like they should have used like a different, like maybe like some like parentheses or something different to specify the size. They ended up using the same for both, so it's on us to know the difference. So the difference is when you define an array, this is what we call the size operator. It's saying what the size of the array is going to be. Any other time you see square brackets after it's been defined, it means it's the index, and it's trying to get an element in the array. We have more practice with this. This is what we did with strings. With strings, we use the square bracket and then the index number to get a certain letter. With arrays, it's the same thing. You put the index number to get the element of that position. Question?
In the house example, you were able to put all the variables on one line, so
Yep.
why is it on a different line now?
So we'll get to that on the next slide. That's the other way of doing it. So to that point, it can be a little bit slow if we had an array of 100 elements, if we had to go element by element to add values. If we had to do like ages of 0 is equal to this, ages of 1 is equal to this, ages of 2 is equal to this, that would be very time consuming. So to Seth's point, we can simplify it and put all the values on the same line. So this is what we call initialization, where we define the array and we assign values on the same line. You can do this with variables too, right? You can say int age is equal to 23. That's what this is essentially doing. Int ages now is equal to these three values. So I'll leave this slide up for a sec. Do people have any questions? All right, I'm gonna have you all, oh yeah, go ahead.
So if we do it that way, we wouldn't have to do like the index thing?
Yeah, we wouldn't have to go index by index later. This would just automatically put them in each of the indexes. Yeah. If you wanted to get a value later, like if you wanted to get whatever values at index 1, then later in your code you would have ages bracket 1, and that would give you the value 9. Okay.
Ooh, can you make it like to where can the user ever input in the array, or it always have to be assigned?
So we'll do that in lab. You can ask the user for a bunch of numbers, and they can be separated by spaces, and then you can see into each of the elements of the array. Yeah. Okay. Other questions? Okay. You can flip over the sheet of paper that you had. Again, try to have each person in the group do one of these, and the others help. This time we're going to create the array of 3 names, so you're still going to define it very similar to how you did before, but now you're also going to initialize it with some values. So again, initialization looks like this. So you still have your data type, you have the name, you have the size, and then you have these curly braces on the other side of the equals sign. Okay? So I'll give groups a couple minutes to do that. You can choose whatever names and letters and test scores you use.
Do you think we have templates right there?
Yeah.
So if you add something to an array, will it automatically change the size?
So that's the annoying thing about C++, right? Is that you can't extend the size. So they created a new data type called vectors, which we'll cover next week, that lets you change the size. Yeah.
Would it look like that?
String names 3. Yep, but it's gonna think these are all variables. So how can you make it so that it thinks of them just as actual? Make sure you use double quotes when you're trying to define strings, otherwise it's going to think you're trying to assign variables to the array. Yeah.
I have been trading. It's not bad. Double quote here and there for names.
So like in the curly braces, we're
Well,
going to have
actually,
3 names.
positive game.
Each of those names need to be in quotes. Otherwise, like if you put just like the name, it's going to think like what variable
doing last week. I
like,
tried
we have to put more in quotes so that
swing trade.
Yeah. If you still send quote-
I think
the same stuff. Yeah.
I think people are on the right track. So array of 3 names, what will this look like? I used some names from earlier today. When I say like, how does it know whether it's a word versus a variable? A lot of times people forget these braces, or these quotes. So it just looks like Idris, and they'll think, what variable is Idris? We have to put it in quotes if we want it to be treated like an actual string word.
You can do that though, like you can assign a variable and then put it the variable.
You could put variables in this list, as long as the variables are the right data type.
Okay.
So these variables would each have to be strings. And then the computer, when it sees the variable name, is just converting that to its string value. Yeah. All right, array of 5 letters. Okay, and how do we define a char? Like single quotes. So we have to put like single quotes A, B, C, D, E, or whatever. Right? Okay, array of 4 test scores. Yeah, and these we don't need to put in any quotes. These are just numerical numbers.
Like, can you like multiply them, average them, 28 and all?
Yeah, so that's what we're gonna do on the next problem.
I'm not bad.
You can. Any questions? Any other questions?
Wait, can I see the last part of it?
Yeah. Okay. So this next one you're gonna do by yourself. You can talk to other people around you if you get stuck, but I want everyone to at least write it themselves. It's gonna be a lot of code. Don't be overwhelmed. What's happening on the first line? On line 6. What's happening? We're creating an array, and we're putting in the numbers 1, 2, 3, 4, 5. Okay? On each line, after each line runs, so on your paper, I want you to just write this first, like 1, 2, 3, 4, 5. That's our initial array. On each line, something is happening. So we'll do the first one together, and then I'll let you all do the rest by yourself. What's happening on line 8? Okay, so what value in this array is nums 1?
2.
Yeah, so we start 0 index, 0, 1, so this is index 1. Nums 1 is this value 2. And what happens to the 2? It gets reassigned to the value 9. So this is what our array would look like after line 8. Okay? So if you need scratch paper, raise your hand, and I'll pass them out. But try to figure out what the array is going to look like at line 14, and then try to figure out what gets printed out on line 21. Anyone else need scratch paper?
You want like we gotta write everything out, or just write down what the new values are.
Just, I mean, it's just 5 numbers you're writing on each line. So I'll just write out the full array each time. Anyone else need paper? Yeah.
I'll take some.
Okay. Once you think you have the answer, raise your hand. I can come check. Yeah, so minus equals, so it's like our minus assignment operator. So whatever the value was in nums2, we'll subtract 2 from it. Tau is raised to the power. So the first parameter, so this would be 2 squared. changed, right? Okay, I think people are on the right track. Let's bring it together and do the problem together. We'll do it in the EdStem. Oops, that's not what I want. Lessons. Okay. So at this point, we said it's going to be 1, then what comes next? 9, 3, 4, 5. Okay? So now we move this here. What happens on this line? So what's the value of nums 3? Yeah, so we count 0, 1, 2, 3. So that's 4 minus nums 2. So 4 minus 3 is 1. So, and we're assigning that to nums 4. So that's this one here. Make sense? Okay. Square root of nums 1. In the earlier class, people were trying to do the square root of 2. What are we actually doing here? Yeah, because nums 1 has changed. We're not looking at the original, like, nums 1. We're looking at what it was currently. And so at this point, nums 1 is 9. So the square root of 9 is 3. And we can put that in the 0th position. Yep. All right. This operation, minus equals. So it's going to subtract 2 and assign it to nums 2. So nums 2 is this one here. So 3 minus 2 is 1. Questions on this one? How we got the 1? Okay. Pow 2, 2. So that's saying like 2 squared. That's going to be 4. And so we actually don't have to change num 3 because it's already 4. Okay. And then here, num 1 is equal to 3. So what happens? Yeah, this 9 becomes a 3. Okay. I forgot one thing. Oh, sorry, I didn't move down this one. Like this 1 came down from here. 3, 9, oh. 3, 9, 3, 4, 1. Oh, all of them, I forgot the 1. Thank you. All right. Wait, I'm still mad. Okay, sorry. Let's try and see. 1, 9, 3, 4, 1. Right? That line's good.
Why is 981? I'm sorry.
Why is this one 9?
I said why is it not 81? Like why is 1? Why is it 1 and not 81?
I messed up something, so let me try it again. So we're at 1, 9, 3, 4, 1. On this one, we do square root, and we store that here. So 3. Got to copy it down each time.
Square root of 2.
Yeah. Minus 2 here, so this becomes 1. 3, 9, 1, 4, 1. This one, nothing changes. This one, num 1 is 3.
Yeah.
Yes. Okay, cool. And so now, this is our array. So in here, the sum is initially 0, the first time this runs. Index is 0. This line you're going to see so many times with arrays. We want to get every element in the array. We're going to use a for loop. I'd say you're going to write this piece of code at least 25 times. It's going to be like index is equal to 0, index is less than the size of array, index plus equals 1. Okay? So the first time when index is 0, what is nums of 0? Yeah, but nums of 0 is 3. So we add 3 to the sum. Okay? Then index becomes 1. So let's also just keep track of our index variable. So now index is 1. What is nums of 1? Also 3. So this, what does sum become? 3 plus 3 is 6. Now index becomes 2. What's nums of 2? 1. So this becomes 7. What's nums of 3? 4, right? 0, 1, 2, 3. So this becomes 11. And then index is 4. What's that? This 1 here. So this becomes 12. And then when index becomes 5, is 5 less than 5? No. So then we exit the loop, and what do we see out as the sum? 12. Do people see how we were able to sum all the elements in the array? Yep. Cool. And we could have done this even if there were 1,000 elements in the array. We would have just had this be less than 1,000, right? Cool. So again, homework party tomorrow, 2:30 to 3:30. This is a hard homework. Please get started on it early. Come in for the homework party. That way if you get stuck, then you can come into Friday office hours or Monday office hours. We'll provide support. And then Lab 9 starts this week. We're kind of a fun lab. We're doing stuff with arrays. So come in today or Friday or Monday. Yep. Cool. Thanks, everyone.